I'm Professor Gibson, and this video is about ratios and proportions. So a ratio problem usually just has one fraction in it, kind of like a percent problem does. Sometimes it will have two. Typically, you're comparing the two ratios somehow. That would be like what our first example does. Karen mowed grass for 14 hours and mowed 11 yards. John mowed grass for 10 hours and mowed 7 yards. Who mowed more yards per hour? All right. Well, the ratio for Karen, so it's yards, so it's per hour, right? That tells you the pers like to divide the hours in the denominator. So Karen mowed 11 yards in 14 hours. This was Karen. All right. 11 out of 14. What does that turn out to be? It turned out to be 3 decimal places, 0.786. Okay. Then John, all right, mowed 7 yards in 10 hours, right? So that's do the division there, it's 0.700. 786 is the bigger number. Karen's the winner, right? She mowed more yards per hour. So this is a ratio, it's just a fraction, all right? Here we're comparing two ratios. Now a proportion problem has one ratio, equal to another ratio. All right. So here's a typical proportion question. 3 out of 7 students at John Tyler Community College take Math 154. I have no idea if that's accurate. I just made that up. All right. If there are 9,500 students at JTCC, how many take Math 154? Round to the nearest whole student. All right. So on the one hand, we have 3 out of 7. Okay. On the other hand, we have an unknown number taking 154 out of 9,500. So we'll let unknown number and then out of the 9,500. All right, so this is a proportion. The equation is one fraction equal to another. Now we just have to solve for the one we don't know. We'll do that by multiplying both sides by 9,500. We get x equals 3 over 7 times 9,500. All right, that turns out to be, rounded to the nearest whole student as it says, 4,071 students. All right, that's it for ratios and proportions. I hope you found that helpful.